Submarines are terrifying. They can travel through deep waters, undetected by ships on the surface, meaning they're ideal for subterfuge and launching unexpected attacks on opponents. More recently, they've taken on a nuclear slant, with countries like the US, Russia, and China designing subs that are capable of firing submarine-launched ballistic missiles, or SLBMs, carrying nuclear warheads. Yet, submarines are not without their disadvantages. But what if we told you that the US has been developing a submarine that eliminates almost all of them? A submarine that's so easy to build and deploy that the maintenance problem is mitigated massively. A vessel that is completely unmanned and entirely autonomous, meaning the human risk of operating submarines is taken out of the equation. And perhaps most importantly, a submarine that moves so quietly through the water that modern equipment isn't capable of tracking it. A submarine sounds like a sci-fi creation. It isn't. It's a reality, and it's named the Manta Ray, the latest US military innovation that terrifies China and threatens to end Beijing's efforts to build its influence in the Indo-Pacific. So what is the Manta Ray? In June 2021, the War Zone provided some details, starting with dubbing it a submarine that looks like a docked Star Wars ship. Using satellite imagery to back up its claims, it says the Manta Ray is a submersible drone being developed as part of a Defense Advanced Research Projects Agency, or DARPA, project, with the submarine intended to be able to complete a host of naval missions. The submarine the War Zone examined is based in Naval Base Ventura County, a Californian base that focuses primarily on the research, development, and testing of new weaponry. It's estimated that the underwater drone's wingspan is around 45 feet, with its overall length being 33 feet. Again, the Star Wars reference comes into play, as the images we've seen so far make the submarine look more like a futuristic plane than a submersible vessel. This size places it somewhere in the middle of the spectrum of unmanned underwater vehicles, or UUVs, the US military has in development. The Manta Ray is shorter than Boeing's Echo Voyager, for instance, which measures 51 feet long but is also much thinner. However, it's larger than the Remus 600, which is 10.6 feet long and barely over a foot in diameter. However, these dimensional specifications are estimates. Neither DARPA nor the Manta Ray's manufacturers, Northrop Grumman, have released official figures for the submarine's size. That suggests that development is ongoing, meaning the estimates the War Zone reports may change once the submarine enters service. Speaking of Northrop Grumman, the company provides more details about what the Manta Ray can do on its website. It describes the UUV as a new class of submersible, with its design being directly inspired by the winged fish that lends the sub its name. The Manta Ray is designed to conduct long-range and long-duration missions, with a focus on ocean environments that humans are unable to explore in traditional submarines. Better yet, for the US Navy, the Manta Ray is capable of conducting payload missions, meaning it can not only reach places that regular subs can't reach, but can also carry munitions, such as bombs and missiles, to attack targets. The Manta Ray is also a modular vessel. At least that's the indication received from how Northrop Grumman shipped the submarine from its manufacturing site in Maryland to Naval Base Ventura County. Naval Technology reports that the UUV was shipped piecemeal, meaning it was broken down into sections that allowed it to be easily transported via road to its destination. Once it arrived, the Manta Ray was quickly reassembled, ready for testing. A clear advantage over traditional submarines emerges. A regular sub can't be transported so easily. With the Manta Ray, the US is getting a vessel that it could disassemble, transport to anywhere in the world via on-road vehicle, plane or ship, and then reassemble so it's ready to deploy. Furthermore, this piecemeal approach suggests that Northrop Grumman will be able to easily manufacture the vessel, as well as create replacement parts for existing Manta Rays. Damage to one of a Manta Ray's wings, for instance, may not mean the entire vessel has to go in for repairs. Instead, the broken wing can be switched for a new one, with the UUV getting back underwater again far faster than even a slightly damaged submarine will be able to do so. All very impressive so far. However, the two real difference makers for the Manta Ray come from how it's powered and how it navigates. Starting with powering the vessel, DARPA's chief engineer for the Manta Ray program, Brian Theobald, developed a novel idea. A 13-year veteran of Northrop Grumman's previous UUV projects, Theobald began working with a renewable energy technology company named Seatrek to come up with a way to harness and harvest the ocean's inherent energy to keep the Manta Ray running. This partnership led to Seatrek creating a set of energy harvesting products that make use of an ocean's thermal gradient to generate the electricity needed to operate a vessel. This gradient is the difference in temperature between an ocean's surface and the waters below, with the surface waters typically being the warmer of the two. Thanks to Seatrek, the Manta Ray is now equipped with technology that essentially allows it to keep itself charged with the electrical energy it needs to run without ever having to surface. In short, the Manta Ray is capable of staying out at sea almost indefinitely, constantly delivering mission data as it does without needing to return to port. Instead, it can travel to various electricity storage locations to recharge. Plus, the fact that it doesn't need to resurface and can actually sink as low as the ocean bed makes it incredibly difficult for another country to track the UUV once it's at sea. Creating these capabilities didn't come without challenges. For one, Theobald's team needed to figure out a way to transfer the new energy its new system stored to the various rechargeable autonomous systems built into the Manta Ray. That required a new invention, Niobicon. This self-insulating electrical connector tech is the brainchild of Jim Windgasson and Harvey Hack, who are both Northrop Grumman employees. Together they created a connector that's capable of being mated and demated even when exposed to water, eliminating the need for oils and rubber seals to prevent water from impacting an electrical connection. The connector's success all comes down to an element named niobium, which transforms into an ultra-thin and passive film the moment that it makes contact with water. As Windgasson explains, the film prevents current from leaking from the contact into the water. When the connector's two halves are mated, the insulating film is scraped off, allowing current to flow unimpeded through the connector. Once the current is no longer flowing, the film reforms upon contact with the water, and the Manta Ray is recharged and ready to go. So how does the recharging station work? Dubbed the Mission Unlimited UUV Station, the device is currently in its conceptual stage and is yet to be developed. But according to Theobald, it'll be deployable from a ship, after which it sinks to the bottom of the ocean and anchors itself. The station will then release a thermal energy harvesting pod, which is propelled up, generating and storing electricity thanks to the thermal gradient method mentioned earlier. After a few days, the pod will have gathered enough energy to fully recharge a Manta Ray UUV, after which it heads back down to the charging station to be stored until the submarine needs it. Assuming the station is successfully developed, it's likely that the US will deploy dozens of them in the oceans around the world. In doing so, it'll create a network of charging stations that enable the Manta Ray to stay underwater indefinitely. Better yet, the UUV will be taking advantage of an energy resource that's never going to run out. That's according to Kelly Rule, who is a mechanical engineer working with Sandia National Laboratories. Rule, who also serves as an advisor on the Manta Ray project, says, "One of the things that's really interesting about ocean resources is that they're persistent. In other words, the waters never run out, and the waves never stop." According to Rule, this persistence not only means the ocean itself is an unlimited energy resource for the Manta Ray, but there is also potential for the production of power at a wider scale, especially if a device is developed to capture and transfer the power of ocean currents. Those are ideas for the future. For now, the US has a submarine in development that can theoretically operate underwater perpetually. Still, the energy issue wasn't the only challenge that Northrop Grumman's engineers faced. The communication of information was another. How do you transmit data from a vessel that's always underwater and has no humans on board to an appropriate source? Again, the insulated connectors built into the thermal energy pods the Manta Ray will use to recharge itself come into play. Those connectors not only transfer electrical current, but can also be used to transfer data from the Manta Ray to command bases on the shore. How? A clever technology that Northrop Grumman calls data bubbles. Theobald explained these devices. Data bubbles are tiny electronic devices that store data. When released from the station, they float to the surface and begin using their RF satellite communications antenna to transmit data to shore, to satellite, or to a ship. It's an ingenious solution to a communications problem inherent in having an almost permanently underwater vessel. The Manta Ray itself never needs to surface, meaning it can't expose itself to enemy surface vessels to send data to its operators. Instead, the transmission of data is handled automatically whenever the UUV docks at a charging station, with the tiny data bubbles being capable of sending any information the UUV gathers with no chance of it being spotted by an enemy. How does this differ from the way traditional submarines communicate? Sandbox provides the answers. It points out that most above-surface military platforms, including ships, planes, and vehicles, communicate via radio. That's fine when you're above water. Radio waves can travel freely through the air. But a problem arises for submarines because radio waves get lost in conductive salt water, such as that which makes up the world's oceans. To compensate for this, American submarines currently use very low frequency, or VLF, transmissions to communicate information back to their bases. These transmissions rely on the creation of enormous antenna complexes, which the US has built in 5 places around the globe. Those installations are vulnerable. If the US found itself at war with a country that's capable of firing missiles at these antenna complexes, such as China, it could find itself quickly losing the ability to communicate with its submarines using VLW. It has contingencies in place for if that happens, claims Sandbox. For instance, the Take, Charge and Move Out, or Tacoma, aircraft are tasked with flying out to a submarine's location so they can deploy 5-mile-long antennas while flying in overlapping circles to receive messages. But that only creates more problems. Planes and antennas then become targets, in addition to giving away the general position of the submarine with which they're trying to communicate. The Manta Ray's data bubbles solve these problems. While it's still possible that the Manta Ray will also be equipped with VLW, why not build it in if you have the infrastructure in place to use it? It will no longer be reliant on the technology. An enemy could take out every VLW antenna station and fail to put a dent in the Manta Ray's ability to transmit information to US command posts. Let's summarize what we know about the Manta Ray so far. The UUV counteracts many of the disadvantages of modern submarines through the use of a host of systems and sensors that allow it to stay underwater for as long as needed. It can be transported in pieces and assembled at any suitable location, allowing it to be deployed from practically any American military base in the world. Considering the fact that the US has around 750 bases spread across 80 countries, it benefits from a multitude of deployment options that could theoretically allow it to send dozens, if not hundreds of Manta Rays into the world's oceans. Once deployed, the UUVs can descend to depths no traditional submarine can reach, which is useful for both collecting data on the subs that it encounters, as well as for its novel method of recharging. Speaking of recharging, the innovative charging stations Northrop Grumman is developing not only allow that charging to happen while underwater, but serve as communication points thanks to their data bubbles. In short, the US is developing the next generation of undersea technology with the Manta Ray. There are still challenges to confront before the UUV can be deployed. For one, much of the technology behind the charging stations is still theoretical, meaning it may take several months or years before it reaches a point where it can be reliably deployed. Northrop Grumman will also need to find a solution for the undersea corrosion issue. Constant exposure to salt water could wear away at the Manta Ray to the point where it's forced to return to base early for repairs. There's also the pathfinding challenge, as the Manta Ray is a UUV with no human on board to control its direction. It's likely that Northrop Grumman will implement artificial intelligence here, likely combined with an array of sensors that allow the Manta Ray to identify its surroundings so it doesn't crash. These are all challenges that Northrop Grumman and DARPA will confront during the testing phase, a phase that is already well underway. In May 2024, DARPA announced that a Manta Ray prototype had completed a full-scale in-water test around the Southern Californian coast. The tests, which took place between February and March, examined the craft's aerodynamic performance with a focus on submerged operations. Buoyancy, control, and propellers were all tested, allowing DARPA to confirm that the submarine could steer while propelling itself through the water. DARPA's Manta Ray program manager, Dr. Kyle Werner, confirmed that the tests went well. Our successful full-scale Manta Ray testing validates the vehicle's readiness to advance toward real-world operations after being rapidly assembled in the field from modular subsections, said Werner. In other words, the new UUV works, both in terms of its undersea operations and when it comes to being transported piecemeal to a location so it can be assembled and deployed. By now it's clear that the Manta Ray is an extremely impressive piece of equipment and will only grow more impressive as DARPA and Northrop Grumman get their supporting systems up and running. But there's one country that will be watching these developments because it's terrified of what the emergence of the Manta Ray could mean: China. As part of its massive military modernization, China has been building submarines at a rapid pace. That's according to a July 2024 Newsweek report, which claims that satellite imagery shows that China is building new diesel-fueled submarines to go along with 48 it already has. Of those 48, 21 are Type 039A/B submarines, also designated as the Yuan class by NATO, which weigh 3,600 tons and are capable of firing missiles at ships. Newsweek claims the Pentagon believes China has ramped up production of these Yuan-class subs to the point where it'll have 25 more of them by the end of 2025, bringing its total diesel-powered submarine stock to 73. That's on top of the 12 nuclear-powered submarines China currently operates. The message here is clear: China is trying to dominate under the waves. It's amassing a fleet of submarines that will give it a stronger presence than both Russia and the US, which currently have 65 and 64 submarines respectively. The problem for them is that the US is now playing chess while China is stuck playing checkers. As China invests more into building traditional submarines to expand its underwater reach, the US is investing in unmanned and revolutionary new submarines that represent the next generation of technological advancement with this type of equipment. As is so often the case, China is playing catch-up to the US. Once the Manta Ray is ready to deploy, China will be at a clear disadvantage because it will be restricted by the fact that its submarines are massive machines that require consistent maintenance and can only really move from place to place under their own steam. The US won't have those restrictions with the Manta Ray. Remember, this is a small submarine that can be disassembled and transported to almost any location in the world. That means the US could pack it on a plane if it wished and fly it to a dock from which it could be reassembled and deployed. Why does this matter when it comes to China? Earlier we mentioned that the US has 750 military bases spread around the world. An enormous 120 of those bases are in Japan, with another 73 being in South Korea, both countries with which China is vying for control and influence over the Indo-Pacific. In particular, China is attempting to control the South China Sea, through which around a third of global shipping passes. China believes it owns almost the entirety of that waterway, which is a claim disputed by a host of countries, including the Philippines and Malaysia. The tussling over the South China Sea has led to China taking a submarine-heavy strategy in its waters. This was revealed back in 2016 by the BBC, which noted that China was building up a nuclear submarine force that would use the South China Sea as headquarters of sorts, from which China could break out into the Pacific Ocean as it saw fit. In particular, China has deployed Jin-class submarines into the South China Sea, with each being armed with up to 12 JL-2 nuclear missiles. The intention is clear. Those submarines patrol the depths of the South China Sea, lying in wait just in case they receive the order to attack another country, such as the United States. Key to that strategy's success is subterfuge. The subs need to be able to cross over the Pacific Ocean undetected so they can get within range of the United States. This is where the Manta Ray presents a serious problem. Before the creation of America's new UUV, Chinese submarines essentially controlled the South China Sea, but more importantly, they were incredibly difficult to detect, leading to the US having no idea where they might be at any given moment. With Manta Rays deployed from bases in South Korea and Japan, the US now has the ability to send an almost undetectable fleet of UUVs into the South China Sea to keep tabs on what China is doing. Those UUVs never need to surface, assuming the technology is developed to the point Northrop Grumman hopes, and can use charging stations on the ocean bed to send information back to US command. In short, China's traditional submarines won't be able to do a thing about the Manta Rays gathering and transmitting information about them. Even if a Jin-class sub spots a Manta Ray in South China Sea waters, the Manta Ray can descend to depths the Jin-class can't reach. And worst of all for China, if war did break out, the fact that Manta Rays can be equipped with a payload means the US could use them as kamikaze weapons to take out China's subs. After all, the UUVs are unmanned and, by all reports, appear to be easy to manufacture and assemble now the technological aspects have been confronted. Where does this leave China's submarine strategy? As recently as August 2023, China was running anti-submarine drills in the South China Sea, but those drills showcase how far behind the times China is when compared to the US. Reuters reports that the drills involved China sending out a dozen patrol craft, which were tasked with flying for 40 hours over the South China Sea to search for submarines that might be surfacing. Those planes also simulated attacks on the submarines they spotted. These drills will be useless for dealing with the Manta Ray. A UUV that never needs to surface can't be spotted by patrol aircraft. Again, the chess versus checkers analogy comes into play. The US is developing a threat to China that upends every measure China has to guard against that threat. While Beijing is trying to figure out how to locate traditional submarines, it'll be completely in the dark when it comes to the ghost fleet of Manta Rays that may be coming. Therein lies another problem for China. Detecting Manta Rays will be almost impossible using current techniques. The maritime patrol aircraft strategy it was practicing back in August 2023 has existed since the First World War and has proven effective against traditional subs. The aircraft scans a large area of the sea, looking for surfacing subs or even their periscopes. Modern aircraft even have sensors that allow them to detect the heat from vessels that may be submarines. A diesel-powered sub, for instance, generates a distinctive heat signature that can be detected if it's near the surface. That signature doesn't exist in the Manta Ray, thanks to it being electrically powered. The UUV also doesn't need to surface to use a periscope. There's nobody inside to examine the surroundings anyway, making patrol aircraft pointless in combating America's new submarine. The only thing they could possibly scan for are the thermal energy harvesting pods the charging stations release. Devices so small, they'll be almost impossible to spot. And even if the patrol aircraft spot a pod, they've only found the location of one of what could be dozens, even hundreds of charging stations under the sea. They haven't found a Manta Ray. Beyond simply looking for periscopes and emerging submarines, patrol planes can also be equipped with magnetic anomaly detectors, or MADs. These magnets are placed in a pod at the rear of the aircraft to isolate the electromagnetic noise the aircraft itself generates. With that isolation complete, the MAD sensors scan the Earth's magnetic field to pick up on sound-based anomalies. This could reveal the presence of a submarine under the water, though only when combined with sonobuoys dropped by the aircraft, which are used to pick up sounds. That won't work against the Manta Ray either, as the UUV barely generates sound, and certainly not to the level that a diesel-powered submarine would. Where does all of this leave China? It's facing the prospect of a United States that could, in a few years, deploy dozens of Manta Ray UUVs into the waters it wants to control. These new submarines will be practically undetectable, allowing the US to gather data about Chinese operations and submarines, and could even be used to attack Chinese subs and ships thanks to their ability to carry a payload. Billions of dollars China has invested in traditional submarines could ultimately be rendered moot, as it once again finds itself playing catch-up to a technology that another nation has invented. Still, it's worth pointing out that the Manta Ray and its many supporting systems are not operational yet, despite the submarine itself having undergone several successful tests. We'd love to hear what you think about this UUV and what it means for China. Could the US use the Manta Ray to dominate the South China Sea and thwart Chinese plans? Share your thoughts in the comments, and thank you as always for watching the video. Now go and check out Australia Shocks China by Revealing New Secret Weapon, or click this other video instead.